Here's a new problem, and I'll read it off to you to make sure you can read my writing. Solve 5x plus 3y minus 4z equals to 4. 3x plus 2y plus 5z equals negative 7. And negative 2x plus 7y minus 3z equals to 9. Alright, so I'm not going to do anything really a whole lot different from the last example. I just think that you probably could use another one. And because this is a pretty involved process, as you're beginning to notice, I'm sure. And because of all the details, it's very easy to screw up something, to misplace a sign or do an arithmetic error. And so try to be organized best you can. Well, let's talk through it. Shall we eliminate x, y, or z? And I don't think it matters a lot. Let's eliminate x. So I'm going to pick on x, and let's label the equations again. There's equation 1, 2, and 3. So I'm looking at these, and I'm thinking the negative will cancel with a positive pretty well. So how about we cancel negative 2x down here with a 5x, and we would do that by multiplying the top equation by 2 to make it 10x, and this one by 5 to make it negative 10x. So I've got 2 times equation 1 gives me 10x plus 6y minus 8z equals to 8. So I multiply 2 through the entire equation, including the right side. And I need to multiply this equation by 5. So plus 5 times equation 3 gives me negative 10x plus 35y minus 15z equals to 45. So let's see, 5, 35, negative 10, 35, negative 15, and 45. I want to make sure I don't make a mistake, because it's sad when you make a mistake and don't catch it for quite a while, because it's a lot of work, isn't it? Alright, so add these equations. X's cancel. I get 41y minus 23z equals to 53. Alright, so this was using the first and third equations. And now we need another equation, because I can't get a number for y or z out of one equation. I need 2 equations with y and z. So I need to make a separate combination here. And I'm going to pick on equation 2 with equation 3. So we'll make this separate combination of equations. And remember, to solve these, you have to use all 3 equations somehow. So what will we do? Well, 3 and 2, we'll turn that into 6. So I'm going to multiply this equation by 2. So 2 times equation 2 gives me 6x plus 4y plus 10z equals to negative 14. And then I'm going to add 3 times equation 3. And this gives me negative 6x plus 21y minus 9z equals to 27. Okay, so I want to double check my numbers here and also make sure that looks more like a 27. Alright, so 2, so 6, 4, 10, negative 14, multiplied by 3, so negative 6, 21, negative 9, and 27. Alright, you notice how I like to kind of double check what I've written, all my little calculations. And I like to catch those errors ahead of time in case I make some. I don't always catch all my errors, but when I check my answers, I'll know if I have an error. So, good habits to produce. Alright, so add these equations. The x's cancel, and I've got 25y and plus z equals to 13. So we're left with 2 equations with y's and z's in them. Right here and right there. Now, I have the luxury of being able to erase easily, but please don't do that on your paper if you're turning it into me, because I would like to see your work. And you will score better when you make errors if I can figure out how you made the error. In many cases, if it's a small carelessness rather than a big conceptual mistake, then I can be generous about partial credit. So you want to communicate what you're doing to me. All right, well, I need to do some erasing here. So let me clear off everything but these two equations I need. And there they are. And how about I recopy these? So I've got 41y minus 23z equals to 53, and 25y plus z equals to 13. Well, I think things are going to get a little ugly here. I'm going to have some big numbers, but I think probably you have a calculator. So do I. Rather than try to mess with common, least common multiples with 41 and 25, I'm looking at negative 23 and positive 1. If I multiply this equation by 23, then I'll be able to cancel the z. So I'm going to now cancel z. I'm going to recopy the first equation, 41y minus 23z equals to 53. And then multiply here. 23 times 25 would be 575. Y plus 23z equals to, oh boy, 13 times 23, 230, 299 I think. I want to double check that. So 13 times 23 is 299. Now you might wonder, how come it was harder for me to multiply 23 times 13 than it was to multiply 23 times 25 in my head? And it's algebra. I know that 23 times 25 happens to be 24 squared minus 1 squared. And so if you know what 24 squared is, as I do, then you get 575. So I'll leave it to you to ponder how this works. But I know a few of those tricks, and they're all based in algebra, and nothing that exotic. All right, so back to this problem. Going to add these equations together. So 41 plus 575 is 616. Y. Okay, I just want to make sure I'm doing well. 53 and 299 is going to be 352. So y will be that number. So we get kind of ugly here. Maybe looks like we can reduce this somewhat though. 352 over 616. Let's see, 352 divided by 4 is 88. 616 divided by 4 is 154. Let's see, that would be 44 over 77. Divide by 11, I get 4/7. So y equals to 4/7. Okay.